Hey guys, Mr. Catlin here with your virtual lesson for 4.7. It is Tuesday and we are working on these tape diagrams. Yesterday we connected the tape diagrams that you see similar to here to descriptions like increases by fractions, changes by fractions, increased by a quarter, decreased by a quarter, increased by a half. You take that distance and you go up or down by a fractional amount. So today we're going to take that idea and then we're going to extend it into these equations that match with it and have this decimal number that tells us that we can multiply by it to get the increase or decrease that we desire. Okay, so this first question that I've got right here set up for us is I've got two diagrams. I've got 5 descriptions and 5 equations, one diagram to one of each. So let's start with in these tape diagrams, just imagine that the section that is fully colored in this scenario is your whole. Okay, so imagine X is your whole. That's everything. We have taken the whole and we have split it up into 1, 2, 3, 4. So we have split it up into quarters. So I know that this particular diagram is either going to go with this one or decrease by a quarter, increase or decrease by a quarter. And so think of the y as the part or where you end up at after you have done something with your whole. Now we have gone from here back down to there. So we've clearly decreased or we've taken a quarter away from this whole. All right. So I like to think of it with numbers. So let's say that x was equal to 40. Okay. If x's length was 40, then that means that every one of these quarters would be equal to 10, right? 10, 10, 10, and 10. We have taken one of those 10s away, and 10 out of 40 is a quarter. So for this particular diagram, we have decreased by 1/4. All right, let's do the same thing for the other one before we get to the equation part, just to make sure we get this part right, okay? So let's say that x is 40 again, just to clarify here. X is 40, 10, 10, 10, and 10. This time we've taken that section and we've tacked on another to tell us what the distance of y is. So y is not a decrease by a quarter, but we've taken that extra quarter and we have increased it. So that would be matching with those descriptions, okay? So taking away a quarter, adding on a quarter. Those are the two descriptions that match our diagrams. Now to translate that into equations, what does that mean? What does that look like if we wrote that as an equation? Okay. So the way that I like to think about these equations is I like to break down the fractional part and then convert it into its decimal equivalent. Okay. So in terms of y, if we look at what y equals over here to the left, okay, for the first one, the one where we decrease by a quarter, we have 1, 2, 3 of those quarters. Y is 3/4 of what x used to be. So which one shows y equaling 3/4 of what x used to be? Well, that is right here because 3/4 is equivalent to 75 cents, right? It is 3/4 of what x used to be. We also could have written it like that in fraction form, but now we're getting it as a 75 hundredths in decimal form. So we're going from the fractional to the decimal. We will eventually be going to a percentage in the next lesson where we say this diagram A is representing a 25% loss or a 25% decrease. Let's look at the last one. Okay. Uh, X is 40, right? We're just going to say that this is 40, and we've tacked on an extra 10, right? We've added an extra quarter. So when you begin with your full amount of 10 or 4 tens, you had 4 quarters, 4 full quarters, right? 1/4, 2/4, 3/4, 4 quarters, and this right here would have been your 5th quarter. So y, the length of y, is 5/4 of what x used to be. Now, 5/4, if you convert that into decimal form, 5 divided by 4 equals 1.25. And if you know your money very well, you know that 5/4 is equivalent to 1.25, which is why this description lines up with this equation. Because if I take the value of x and multiply it by 1.25, I will get the value of y. It's going to grow because it's greater than 1, and its constant is greater than 1, so it's going to make it grow by 1/4. Same thing up here. This one's less than 1, so it was a decrease. This would have been an increase. This would have been an increase. This is an increase. And then everything that I'm going to mark here in red, those are decreases because they're less than 1. Your number in front will tell you whether it's an up or down type of change. All right, let's put that into some practical use on this problem with Kieran. Okay, so Kieran has read for X minutes. So let's go ahead and let's label that. Let's say that this tape diagram right here represents the amount of time that Kieran has read, and we will call it X. Now, before I even move on, I'm going to look at my fractional part of what Andre did, and I notice that it's eighths, 5/8. So I'm going to go ahead and I'm going to split up Kieran's reading into 8 parts. Okay, 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8. Andre read 5/8 more than this. Okay, so if I was going to draw a rectangle to represent Andre, okay, he read everything that Kieran read, right? Everything that he read, plus an additional 5/8. So that would be 1, 2, 3, 4, 5. This distance right here that I'm marking in blue, these 5/8 marks that I've marked, that's the additional that he read extra. So I'm going to try my best to represent that with a good drawing. Okay, about that length. And I'm going to break that into 1, 2, 3, 4, 5 equal parts. So 1, 2, 3, 4, 5, right? 5 extra eighths. And these first ones were broken up into 8 equal parts as such. Okay. So this distance represents the amount that that Andre read, because he did 5/8 extra. Okay. Now, what they want us to be able to do here is they want us to be able to represent that with an equation. All right. So with decimals. So let's first of all, let's start with if y is representing Andre and x is representing Kieran. Okay. Kieran read an entire 8 out of 8, right? That is his amount. And Andre read 8 out of 8, which is all the way up to here, plus 9/8, 10/8, 11/8, 12/8, 13/8. He had 13 of those eighths in his distance because he had 5/8 more than the 8/8 that Kieran had. So Andre Y is equal to 13/8 of what Kieran read. Y equals 13/8 X. Now, if you actually change this into decimals, you would simply divide 13 and you would divide it by 8. And you would know that it would go into it one time. And then you would start your process of dropping down your zeros. It will go into 50 6 times, right? 6 times 8 is 48. Difference of 2. Drop down. It will go into that twice. Difference of 4. Drop down another 0. And it will go into that 5 times. So this is the same thing as 1.625 times x to get y. If you take Kieran's amount of minutes that he read and multiply it by 1.625, you will get the amount that Andre read. All right, because he is 13/8 times what he read based upon this 5/8 more. And as we're going to look in this to next lesson, we're going to see that If we converted that to a percentage, if we converted this to a percentage, 162.5%, we could see that he had a 62.5% increase over the 100% that Kieran had read altogether. All right. So using decimals to write our equation is y equals 1.625x. And that represents the growth of 5/8 more than what Kieran had. And that's our lesson for today. That should help you with your cooldowns for Tuesday, December the 8th. See you guys.